Good afternoon, everybody. Good morning to some. My name is Hayley, and I'm the Technical Product Manager looking after the CAD. So this presentation is going to go through the new reverse engineering module for Designer. So it's brand new for 2021. I'm going to say it should be less than 2 hours. I'm aiming for less than 2 hours. Otherwise, it's getting a bit long. I'm going to do a little overview of the new reverse module, a very, very brief introduction to reverse, because it's completely new to some of the applications. Got a few tips and tricks to start with, things to be aware of in Designer. And then I'm going to go through 2 demos. We've got one prismatic, more prismatic demo, including some simple freeform parts. And then we have a completely freeform sheet metal part. And at the end, I'll do a Q&A. I'll try and answer all your questions. So this is the information for the new reverse module. It's a single module, and it bolts onto the Advanced Designer license only. It's available to these brands: AlphaCam, EdgeCam, Raydan, SurfCam, and WorkC. And I've put the price on there and a little disclaimer that that's the price as of the date today. And of course, it's always subject to change and also regional differences. You do need to have quite a powerful PC if you want to be doing live data acquisition or live scanning directly into Designer. So this is the recommended hardware spec, and it is worth noting for the RS6 laser scanner. So that's the new hexagon scanner that was released at the end of last year, and it's the same recommended spec for their new RS squared, which is just being released. And I have just got a laptop meeting these requirements. So you are going to have some problems handling really heavy data sets if your machine isn't up to spec. That's just worth noting there. So what is reverse engineering? We throw that term around. And what does it actually mean? So reverse engineering is the recreation of a physical model into a 3D CAD model. So you can create it by either laser scanning your 3D part, you could do probing of geometric features, or you could do it the old-fashioned way and use a caliper and just measure it, for example, and then redesign it in the CAD model. So you can replicate, enhance, or change existing physical models. So you may want to do this if you don't have the original CAD model, for example. A very simple example is if you want to create a phone case or a bike computer mount. You need to get the exact topology of the element you want to mount or to create a case for. And you can do that by using a laser scanner and replicating it. Another example is for prototyping. Some designers like to create a physical model and sculpt it with their hands, and then they can scan the model in and recreate it, the proper final CAD model for manufacturing and mass production. You can use it to repair tools. If you have a small region that is damaged, you may only want to scan and recreate the problem region. So there's loads of different applications for reverse engineering. Okay, so I'll start with a couple of tips and tricks for Designer. Just things I think you guys should be aware of, and I can show you in the software as well. Okay, some of the commands have many options. There's 23 brand new commands in this new module. So you can imagine I'm not going to be able to go through every single option in every single command. So if you're in doubt of what anything means, don't forget you can press the F1 key inside any command to open up the contextual help. So we don't have the complete set of online help ready yet. I think we've got 8 or 9 commands documented, but all of the rest are going to be documented in the next couple of weeks. Some of the reverse commands have longer calculation times. And if you want to change, say, 3 or 4 modifiers in the dialog, you don't want to have the automatic preview calculating every single time you make a change. So we can turn off the automatic preview. It's a global setting, but you can access it from inside every command. You just hit the little burger button and turn off automatic. And then when you want to hit the preview, you can select that button there when you've made all the modifications that you need. And then you've got to remember to turn it back on again when you want to see the preview, of course, and you want if you're using fast commands. Something that I think is very useful is I always turn the region calculation off as it's unnecessary until we need it. And I always turn the dynamic query on, and then I can get very quick feedback on my point clouds or my mesh to find out how many triangles or how many points we've got in my model. And then I've got to throw this in there, my shameless plug. Please use the forum if you have any questions. You know, somebody might have already asked that question before, and you're probably going to get an answer quicker if you ask it on the forum because there's more people looking at it. So I've put a direct link in here. I will be providing this presentation and all the parts as well, so you guys can have a go, or you can access it from the customer portal. And there's another link there. So please use the forum. It's a great tool. Right, so now we get into the juicy stuff. So we start with our first part. So some of you may recognize it. It's a hexagon demo block. That's one of the reasons we've picked this part, is because it's widely available and we can use it, and it's been designed with a variety of different features which enable us to show off all the tools in a short and quick space of time. So I've broken this demo up into 4 different sections. So after each section, there'll be a demo in Designer. So after the first one, there's just a video because I'm not hooked up to an arm or a scanner right now, but all the rest are going to be live demos. So we've got data acquisition, then we'll do a cloud to mesh. Once we've got a mesh, we need to do an alignment in space. And finally, we're going to create surfaces and turn that into a solid model and do some comparisons on the original mesh. Okay, so data acquisition. This could be scanning or probing, and you can do this directly into Designer. In order to connect to a hexagon arm, you need to download and install the RDS drivers. If you're using the latest RS6 scanner, you need the newest version of the drivers, which is 5.3. And then you have to configure your RDS settings in the control panel according to whichever hardware setup you've got. So it is all very dependent on which device you're using. So once you've got that all set up, you'll be able to run Designer 2021, and you can start scanning directly into Designer. So what we're doing first of all here is creating a clipping plane by probing. So we create 4 points, then a work plane is created using those points, And then when we start scanning, we can use that clipping plane and say, ignore everything underneath that plane. That means we get a much tidier scan. We don't get any data that we're not interested in. And it's a much lighter weight data set. And then here we are, scanning using a hexagon portable arm. I think that's a 2-meter arm. And we can scan that hexagon demo block. When you've got everything, you stop the scan, accept, just like all the other commands in Designer, and you've got a point cloud created. Now what we're doing is just turning that part over so we can scan the underside. So what we'll end up with are 2 point clouds, one of the top and one of the bottom. So it can be quite nice to scan some of the same features twice, because it can always help us with our alignment. And you can see here we've got the number of points shown. So we've got 5-6 million points required. And we've got this automatic rotation. So as you move and scan the part, you can always see the point cloud in your window. And this is all real time as well. I've not sped anything up here. This is completely real time. Okay, so that was our data acquisition step. We did probing of the clip-in plane, and then we did 2 scans. So that takes us to our next step. We've got 2 point clouds, and we need to convert it into a nice quality mesh that we can use for all of our reverse commands. So what I'll do in this next step is to align the 2 separate point clouds so they are one, merge them together. I'll do a filtering operation to make sure we have a nice lightweight data set, and then I'll create the mesh. There's a couple of different methods in order to create the mesh. We could use the individual steps, which is going from a cloud to a mesh, then using an individual command to refine, and then another command to do a smoothing. So you've got absolute full control if you use this method. Or we have one step which combines all of these commands listed. So you can even do the point filtering inside the one-click mesh. So you can do it in one step rather than having the full control. So it all depends on the topology of the model that you're working on and how well you know the system or which numbers to input. And it's purely up to you which method you like to use. From my experience, I like using the individual steps just because you have got that more control. But maybe in a demo scenario, it could be nice just to throw a one-click mesh on and you get a really nice output without much input. So just having a quick look here, on the left, the purple is the output from the cloud to mesh, and on the right is a refined mesh. So it's just tidied up and sharpened up the corners and the edges. Here we have the refined mesh on the left and the smooth mesh on the right. So you can see we've smoothed out the regions. The hexagon logo has sort of blended in a bit more, and we've smoothed off those sharp edges. So for this part, it's probably not what you would want. Just wanted to show an example. Okay, So I'm going to go into Designer now and do those steps. Okay. So here we've got Designer. These are my 2-point clouds. I've reset everything to the default settings, so I don't have anything set up that's clever going. I can turn my region creation off. So that was one of my tips and tricks. And we can turn the dynamic query on. When I do that and hover over my point cloud, you can see we've got 1.5 roughly million points for my green. And we've got 12 million points for my orange point cloud. So I've already done a filtering operation on this green cloud to make it lighter. So here I'm running the unbranded Designer using the new NGP license, so the internal license, and that gives me access to all functionality. So I've got the sheet metal and the electrode and the reverse tab. So today, obviously, I'm going to be mostly working on this reverse tab, and it has loads of new functionality as well as some functionality that we are very familiar with. I will say this is just going to be focusing on the reverse stuff. So there is an expectation that you have some knowledge of Designer already. So from the reverse tab, I'm going to use the align. And I'm going to align the green mesh to the orange mesh. We'll let Designer do its work. I'm going to keep all of the settings here down the left-hand side default. We'll let it think about that for a second. And there's our result. So because we've got enough information overlapping, this is why I've colored them two different contrasting colors so you can see that alignment clearly. And I'm happy with that for now. I'm just going to right click to accept. So we've still got two separate point clouds. The next step is to merge them into a single point cloud. So I can just Windows select, and then I will have one point cloud in a single color. Okay, so it's gone green. We'll exit that command. So now I should have accumulation of points of my, I can't remember what I had now, 12.5 and 1.5. So now I've got 13 million points. So that's okay, but if I wanted to save this and send it around, it could be useful to have a lighter data set. So I'm going to use the filter points command. First of all, I'll just keep it as default so you can see the result. Select my point set. Okay, so it's using the sampling distance of 1 millimeter, that is. So if I zoom in now, you never know how well this looks over WebEx, but hopefully you can see what's going on there. There's a 1 mil gap between all of those points, and you can see down here, we've gone down from 13.5 million to just over 200,000. So I probably have lost too much data there. So I'm just going to change my sampling distance to 0.1 and say enter. I'm going to recalculate that. You can see we've got a progress bar down here. And the higher the tolerance here, the longer the calculation is going to take. All right, so that, if I zoom out, or zoom straight in, oh, I've lost it. You can see I've got enough information, and I've got 700,000 points. Great. So accept that operation and close it. So now I've got a light data set. I'm going to use my cloud to mesh function. So if you look at our ribbon, we've got a zoom in, if that works. We've got the one-click mesh here. This is our point cloud to mesh panel. we've got the cloud to mesh, refine mesh, and smooth mesh. So I'm going to do the individual steps just to explain each one of those to you. So cloud to mesh, let's just keep the default settings and see what we get to start with. Okay, so by default, the point set is kept visible. So we can turn that off using this option inside the command. We also have the option here to retain original elements. Now, it can be very useful to keep that point cloud to do some comparisons at the end. So I'm going to choose to keep that point cloud. Now we can have a look at our mesh. It looks okay. It's not bad. But if we zoom into, have a look a bit more closely, you can see we've got some holes in these regions, around the corners mostly. So what I can do is check this option, cloud reorganization. That just means the original points can actually move a bit in order to create a more complete mesh. Okay. So just checking that option, I've closed all them holes that were being shown up. I'm going to accept that and close. So you can see my point set is still visible, okay? So I'm going to hide that guy. And I'm actually going to just rejig my layout because I'm going to be using my layers all the time. I'm going to dock that on the left-hand side. We can rename each one of these. So we've got a point set. And I will create our mesh on this layer. Call that mesh. Nice to be organized. You can see we've actually got quite a few different items on there. And that's because when we've created the mesh, some of these points weren't close enough to the original mesh, to the big mesh. So this is all just noise really that we can blow away. And now we're left with one nice clean mesh. Okay, so now I'll do some refinements. So let's use the refine mesh. And I'll pin that guy as well. Again, I'll just keep the default settings. We can select our mesh. And we've sharpened up all those corners like we could see in my PowerPoint. So I'm going to accept that. And finally, we'll do a smooth. I don't want to smooth this part out too much. I want to keep sharp corners. So I'm just going to do one smoothing operation and select my mesh. Okay, so now I have got a nice, good quality mesh. One little bit of noise I can get rid of, and I'm ready to go back to my PowerPoint. So the next stage is to create an alignment. So I aligned 2 point clouds to one another, but they're still floating in space. It's not aligned to anything. So in order to create a nice alignment, so I can create some nice planar surfaces and create a nice square part, if you will, with nice right angled corners, I am going to create 3 reference surfaces. That gives me a nice sharp corner, and I can pop a work plane on there and snap the X and Y directions. Then I'm going to blow those surfaces away and start again. So let's go back to Designer. I'm going to use this layer here and rename it. I will call it Surfaces. And I'm going to use, so this is really where I'm coming in and doing the reverse functions. So I'm going to start by using the plane from mesh function. And the default option is by seed point. So for a plane, that's a single point on a planar region. So I can select that top face Oh, I forgot to show you that we weren't aligned to anything. Where's my work plane? If I just do a top view, bottom, left and right, you can see we're just floating in 3D space with no alignment. So I can create that top surface. If I orient to current work plane, it doesn't make any sense because this is my current orientation. I'm going to add a bit of an extension on there. And I can right click to accept. Now to create these surfaces here, you can see there's a feature in the way. In order to create them as a single surface, I need to change to by triangles method. And by default, it's just in a selection method. So I can just window select triangles if I wanted to. So that's selecting all the way through. Of course, we've got that visible elements option, and that would just select the top layer. That is not how I want to select my triangles. I'm going to choose angular deviation. This means I can hover over my part and get the feedback of which triangles are going to be selected. Right. So if I just increase that value, you can see as I hover over those triangles, I'm going to select most of the triangles in that plane. So I'm going to hold down my control key, or I could use the multi-select and select those two regions. When I let go, you can see that I've got that surface created, fitted through all of those selected triangles. So I can right click to accept that. I'm going to come over here and you can see I'm not picking that face up at all. So I'm just going to up the angular deviation. Now I can see I've got all of these guys. So I'm going to hold down my control key and select all of those. Now I've got 3 intersecting surfaces. Now I'm going to do a trimming operation. Just so you can see what I'm doing, I'm going to hide the mesh. Okay, so now I'm going to use my trim face command, so I can trim faces to one another. So I can select my top and my side, choose to trim both, and right click to accept. So I'll do that again, top and side, right click to accept, and then I just need to trim these 2 side panels. And what that leaves me with is a nice sharp corner where I can position my work plane. So I'll have the center or the origin, then I'll do the X direction, snap the Y direction, and there we go, we're sorted. Now, I'm not interested in these 3 reference surfaces, so they can just be deleted. All I wanted was that nice work plane in a good position. I can bring back my mesh. And if I have a look now and cycle through my views, you can see that we've got a really nicely aligned mesh. So this is all the preparation that's being done, so I can start creating my surfaces. So I'll just head back to my PowerPoint presentation so I can introduce the next step. Okay, so I want to completely reverse engineer the part. How am I going to do that? I'm going to start by creating some surfaces that are intersecting, similar to how we just did it. Making sure I use reference surfaces to make sure I've got a nice flat top and nice straight up and down sides. Then I can trim them together and convert it into a single solid body. Then I need to start extracting features. So I'm approaching this one way, but somebody else might approach this a completely different way and get to the same result. It's not an exact science, reverse engineering. It's how your brain works and how you want to tackle reverse engineering a part, or how you want to break it down into its individual features. So from a couple of experiments, and some of it is just about experimenting with the data that you've got, I'm going to create this feature on the left here, as I think it's more precise. But I did have a play around with extracting that whole feature like so. Then I can pull out the more prismatic features and create patterns of holes. So that's relatively straightforward. And once I've done all of that, I can do a comparison and we can verify and make sure everything is within tolerance. Okay, so here's demo 3, reverse engineering the part. So this is the fun bit, really. What I'm going to do first of all is make sure I've got a nice layer to work on. So let's rename this and call it part. And I'm going to create a cuboid, which is aligned to the work plane. I'm just going to pop him over here. And I'm just going to use that only a couple of times to use as a reference for my top surfaces to make sure we really have got a flat top. I'm going to go to my reverse tab and do the plane from mesh. So I've already had a quick look at this. We can use the seed point to pull out that top face. What we can do now, however, is use the orient to current work plane, and you can see how that makes a nice tidy surface around that top feature or that top surface of mesh. I'm going to use a reference surface, which is this flat plane here, top of this cuboid, and we can make sure it's parallel to that. So that's just a really good starting point. I'm going to right click to accept, and then I'm going to move a bit quicker because you've already seen me do this, and shift or control, sorry, select those guys. This time I want to have a face which is perpendicular to that top face. And then I will do these 4 as a single face. And the orient and current work plane isn't currently working on the ZY plane. So we can just turn that off and it will do a best fit to the selected triangles. And I want to make sure that's perpendicular to my top face. Moving around the part, I can have a look at this side here. I'm going to select, let's do these ones by seed point. I'm not going to give this one a reference. And we can do the front. This guy needs to be perpendicular to the top. And we'll have a look at the bottom seed point. And this one needs to be perpendicular to the side. So all of our tops and bottoms are completely aligned to the work plane, as are our side parts. Now, if we have a look at this wall here, one we haven't done, it's actually a 3D surface. So we can't use the plane from mesh. What we can use now is our mesh to surface command. So if we select that, I'm just going to change the tolerance to be a little bit higher, 0.1. Calculation time's a little bit quicker. And also we don't want to be following every single lump and bump of this surface. As you can see, it's not perfect. It's better to be glancing over the top. So I'm going to choose the triangles to convert. I'm going to use the angular deviation method again. And I'm going to hover over. You can see when I hover over, I've got the feedback. I've not quite got all of the triangles on that face. So I'm going to just up the angular deviation and go back. Now it looks a lot better. And I'm going to select that. And you can see that we've got a surface created which is being trimmed to the triangle edges. Okay, so that's not what we want in this instance. So we can say remove trimming. And we can also add a surface extension. So let's just add 5 mil. So here we've created one surface on one mesh. You can choose to keep the mesh visible or not as well. That's an option inside that command. Also, I can show you how you can turn the automatic preview off as well. Just strange things when I'm on WebEx. So here's the automatic preview. So you access it from this burger bar. You can turn that off. So that means when you make a change in the dialog now, you won't get that automatic calculation. So let me just keep it off for now. I can accept this command and close it down. So we've created all of these surfaces and we can hide the mesh. This guy obviously isn't long enough for us to do our trimming. So I'm going to just use the extend command. It's just a regular CAD command. I can select that edge and I can pull it. Let's say extend face. Should be able to select that edge. Be able to, let's try it again. Extend, single edge. See if we've got it this time. Doesn't want to do an extension for me today. Oh, I've turned off my preview. That's why I've caught myself in my own trap. Let's turn it back on. Don't like it. Okay, there we go. Now we've got the live preview. I did say, didn't I? Don't forget about it. So let's keep it as advanced. I'm going to choose to, you can see here we had new face. Here's our extend original face. Okay, so we just have a single surface there. Okay, so now I'm ready to do some trimming. I'm going to use the trim face, and it's quite quick once you've done it a couple of times. You've already seen me do this. So you just left click, and then you right click to accept. And we are working on a method to improve this for the next release as well, to reduce the number of clicks. So once I've done with this, I will have a nice trimmed sheet body, and then it's dead easy to just turn that into a solid, and then I can start adding and subtracting other features. Okay, so there we go. We've got that 3D surface. It's looking pretty nice. I'm going to use my sew sheets. I'll just turn the extract laminar edges off. Windows select. We've got one solid body now, so you'll see all those sheets disappear. Perfect. Right, so let's bring back the mesh. Let's say I wanted to pull out this feature next, so this 3D feature. So I'm going to do that by, first of all, creating a plane for that edge there. So I can use the seed point. And I will just increase the extension. So we're going all the way to that edge. And I'm going to make sure that I'm parallel. Or, yeah, no, I'll be parallel to this guy. So it's nice and square. Okay, and we'll close that. And then I'm going to view from the other side. Okay, and I'm going to trace this shape with a curve. So this isn't the only way you could extract this feature, of course. But the way I'm going to do it, the way I like to approach it, is to pop a work plane. If I use select position, then we're going to get the Z-axis looking straight at me. It doesn't really matter where I position my work plane. I can just rotate it around so it's in a more sensible location. And we'll accept that guy. Okay, so I've done that so I can project onto a work plane. I'm going to use a wireframe curve and turn on. So this is something that is worth noting, these little filters here. Okay, we're often working on the enhanced pick, but sometimes it's nice to have more control. But also we can use the options which are, we can use alongside these picking options. So that is our project onto current work plane option. It's another one to remember to turn off as well. Okay, so I've got that projection on. I'm going to snap to that top edge, and I can start loosely following my mesh. I'm just panning screen. Like so, and then I'm just going to snap to that bottom corner there and right click to finish. All right, so this is in the preview mode. We zoom in here, I want to make sure this curve is completely tangent with this top plane of face. So I'm going to turn on a start tangency condition. I'm going to pick this top edge. You can see it's the wrong direction by default. I can use my space bar to change that direction. You can see the condition is far too strong right now. So I'm just going to change the scale until it looks a bit more sensible. Once I'm happy, I'm going to right click to confirm. Okay, and then I'm going to use that curve and do an extrude. And we can just extrude all the way to that edge. I just snapped it onto that edge there, okay? It's easier if I hide my mesh. Yep, so just snapped it onto that corner. And we've created that surface. So I'm not really bothered about that wireframe now. I can delete it, and I could even delete that work plane. I'm not going to use it again, and I want to really be working mostly on my origin there that I've created. I need to do some trimming, so I need to use my trim face to trim that face, or that surface rather, to this one. We get this result here. And then I need to trim this face. You can see it goes straight into here. And this time I'm going to use trim surfaces. And that's because this face isn't a single surface. It's the face of a sheet body, or a knitted sheet body. So I need to trim surfaces, select that face, turn off my multi-select, and trim it to this face here. And you can see this is now transparent. So that is correct. Okay. Let's turn this multi-select off. What I now need to do, if we look at this face, it's going all the way through to the bottom. So I just need to trim it so it stops here. So I get to use my favorite command, edit boundary. Select that face. We can get rid of this boundary, introduce this boundary here. And when I right click, we only have the face existing in this region now. I can use exactly the same command. So you can see inside the part now, you see. Hard to see. There you can. And I can do exactly the same on this face here. If I select that face, I can deselect that corner, introduce that face, and we've nicely trimmed exactly to that edge. Okay, so that's all nice and perfect now. All my surfaces are neatly trimmed. These two are separate faces though and not stitched together. So I can do the sew sheets and turn that into a single solid body. Great. All right. So next thing I'd probably like to do is pull out some of those features. Let's hide the solid so I can see what I'm doing. I'm going to use the cylinder from Mesh, so I haven't used that yet. And let's look at this side here. So I'm going to choose by, let's turn that projection off. Use the seed point and select anywhere on that cylinder. So with the cylinders, we can have trimmed or untrimmed geometry. I'm going to have untrimmed, and we can choose to do an extension similar to the plane. We can also use a reference face. This time we've got the option of parallel, perpendicular, or concentric. This time I'm just using parallel to my little cube as my reference, so it's straight up and down. We've also got the option, this is the re-engineering part, because the radius we've got pulled out from the mesh is 24.983. So really, we probably just want to use our spin edit controls to set that to be a value of 25. So I'm going to right click to accept, and we can pull out another cylinder. Okay, so it's pretty similar, going all the way through. This time though, I could turn on my solid and say we want to be perpendicular to that face there. Have a look at our radius value. Again, it's almost 18. Let's just set it to be 18. That's what we want it to be. Right click to accept. Let's turn the solid off. We've got a whole feature here that goes right the way through the part. So I can select here. And to be honest with you, you can select multiple seed points for cylinders. For planes, it's just one, but we have the option. So we can come in here and select another seed point. And that's created a cylinder all the way through that part. So we can say we can have a reference surface perpendicular to that guy, and we can set the radius to be 10 because it's a bit more sensible. Those were quite easy to pull, features to pull out, I think. Let's have a look in here. So I'm going to pull out this cylinder. And we want to have it parallel to here. And we can set the radius to 30. And then the next, so this, we've got the most data on this top one. As you go further down where the laser couldn't reach, we've got less and less data. Okay, so we can select, let's turn the multi-select off. And this time, okay, we want to use the concentric. So we can say concentric to this guy, and it means they've all got the same center point. Again, we can set the radius to be something more sensible. So 20 makes sense. To be honest, I don't need my radius extension to be that big. And apply that. And then down here where we've got the least data, we can come in and say concentric to that guy. Make sure we've got the nice round value. And we've got it. All right, so we'll pull out a couple of planes, again by seed point. And these can be perpendicular to the cylinders. Like so. And then once you've got and extracted some features, what I'm going to do is hide the mesh, which is here in my tree. And I'm going to work with these guys here. So I need to use my extend command to extend this edge here. I can just snap it to the bottom of that because I know that's long enough. Off. And I need to do a little bit of trimming on this feature here. So if I go trim face, I need to trim this one to this one, that one to this one, this one to that one, and then that one to that one. Okay, so that looks nice. I am going to sew that into, because they're all individual surfaces at the moment, sew them together to get a single body. Don't worry about that guy, it's still going to stay separate because it's not linked. And then I can use the close to solid command to turn all of those guys into solid elements, all individual solid elements, okay? Yep. And when I bring back my part, which isn't that one, it's that one, I can just use the regular Boolean command, select my target body, subtract, and window select all of those features. Okay, pretty nice. So if we take a closer look, we've got some holes here in a pattern, and we've got some holes here in a pattern. And if I hide the solid, you'll see if we look down, you can see that we've got the bottom faces, so they're of some of these, so we could know the depth of them, which is quite useful. So what I'm going to do is use my cylinder from mesh and create a couple of cylinders. One here, you can see the radius value could be 8. Let me just set a reference. Let's have parallel to this guy. That gives me the center point of that hole and the diameter. And then I'm going to come in here and do the same for this set of holes here. So I'll just do one guy, do that one there. And we can say he wants to be perpendicular to this one here. Again, 8 mil. All right. So what I'm going to do is use, so if I bring back my solid, I'm going to use my hole command and create a proper drill hole rather than reverse engineering these holes and create a pattern feature. So we'll use the drill hole. I can select that face. I'm going to choose my center point picking and pick the center of that circle. We know that these guys were radius 8, so the diameter is 16. Perfect, that looks right. And now I'm going to use my dynamic section tool. Okay, and I'm going to use it, I think, through the X direction, so we can choose that. And we can just go through our part until about there. And I'm going to have an empty fill. And that means we can see right inside our part. Okay, so we can pull this down until we get the correct result. See what we're looking at there. So we can see a depth of 20 is looking pretty nice. So right click to apply that. Let's go to that dynamic section and just make it so we can see our whole part. We're going to basically do the same thing down here. So we can select the face, we can select the center point. We can see it's been created in the right position, but maybe that's not quite the right depth. If I go to my dynamic section and go to the Y direction, just cut through the part. Let's go the other way. Okay, zoom in there. All right, so we can get the depth. You can see the mesh comes down to here. So we've got 18 mil hole there. Lovely depth that is. So we can apply, get rid of our dynamic section. As soon as you close it down, the cut will go. And we can create a pattern feature out of those features. So let's just get rid of those surfaces I created for reference. Okay, so let's go to our solids tab. We want to do a rotate feature for this top one here. We can shift select the side wall and the bottom. Center of rotation is going to be the center of this feature here. We can pick the Z direction and then we can start. So I've got 1, 2, 3, 4, 5, 6, 7, 8 holes. So I'm going to do 360 divided by 8. That gives me the correct angle. I want to have a multiple copy and we'll have 7 copies. Great. All right, those guys are looking good. Let's close the rotate feature and we can have a look down here. We'll do a translate feature for these guys. Again, I'm going to select the side wall and the bottom face. I'm going to choose to do an incremental move and it's going to go from the center point And I'm saying multiple copy, and we want 3 copies, 1, 2, 3. And I can use the y-axis to move these guys along. And I'm just going to eyeball it till we get it in the right position for the sake of this. So if we have a look now, you can see that's pretty spot on, going all the way around that part. So minus 28. And then I should be able to window select these guys and just do a simple copy. And this time it's going to be a movement in the negative Z direction. And that looks about right, and that's 28 as well. All right, getting there. So what I've done, so we're not doing this all night long, is I've got some features and I'm going to insert them into the part. So if I say File, Insert, and then choose my features, here's some I made earlier. Okay, so we'll insert by node name. Here they are, they're nice and colorful. If I hit enter, it places them on the current or active origin. That's a really useful thing to know about. So let's have a look from this angle instead now. Solid, we don't need it. Okay, so I'm going to do a Boolean subtract. We'll hide the mesh. Target body, and we can select that feature there and remove those guys. You could use a cut bodies as well. Select that feature there. All right. Now, I think we can delete all of those solids and that one. And we've subtracted all of those features. So I just pulled all those guys out in the same way as I've done everything else. So I've got one more feature to create. I'm not going to do the bottom for the sake of this demo. I'm just going to pull out this region here because it uses slightly different trimming technique. So I'm going to hide the solid. We can stay working on that layer. We can activate that layer actually. I'm going to come in here and we're going to pull out some more cylinders. So by seed point, let's bring back my reference solid actually. So by seed point, I'm going to select here. And I'm going to use a reference surface and be parallel. And then I'm going to say 10, and I'm also going to say trim on geometry and just add a little bit of an extension distance there. Okay. I can select the next one, just got 2 more to pull out. I'll use my reference again, round up the radius value, and we'll do the last one. And that one's 15, so we'll just round it down to 15. And then I'm going to pull out a flat plane. So use the seed point method. You can see we've not quite captured everything there. So I'm just going to use this max distance. You can see my cursor trying to highlight it. Increase that value, 0.3, and that now encapsulates all of that feature. Great. So I'm going to do some quick trimming using the trim surfaces, sorry. Trim that one to that one. Trim that one to that one. This one to this one. To that one. All right, so they're all trimmed together. Now I want to trim all of these 3. Hold down my control key to that bottom face there. Make sure I keep some of the results. That's what I'm after. And then I want to trim that guy there to these 3 here. So you see how I've trimmed it like that. All right. And I don't even need to sew these guys together. I'm just going to use them separately. Bring back my solid and we can use the cut bodies. Select my body, and then these are just selected as individual faces. And I can choose to remove one side. So we've got rid of that feature, or we've cut out and created that feature rather. And then we can just get rid of those surfaces, we don't need them. So if we could bring back our mesh, we can add a couple of blends. I'm not going to do loads. This is our direct modeling. This means we can change the design as we've got a full comprehensible model. Add a few blends in there. I'm just using the mesh as a guide. Okay. And then at the moment, we don't have the option to reverse engineer from a mesh automatically cylinders. Sorry, we've got cylinders, spheres or cones. But it doesn't matter because we've got a whole suite of CAD tools at our fingertips. I'll just show you quickly how you can create that sphere. So if we hide the solid and just view from the top, and get rid of that guy as well. I'm going to go and create a circle. We can do circle from 3 elements. I'm going to use the point method and project onto my work plane. Okay. I'm going to zoom in here and I'm just going to say 1 point, 1 point, 1 point, all around the edges. And you can see I've created, hopefully you can see that, I've created a blue circle. And that gives me a good center point. And I can just use that, you see, as a reference to create a solid sphere. I can select my center point, select my edge point, and there's my sphere. I can bring back my solid model and do a simple Boolean subtract. Oh, I haven't cut that feature out. That's interesting. Thought I'd done that. I can't remember if I did it now. Sorry if I forgot to do that. I can use the mesh to surface to simply pull that feature out. No, I don't think I did. Let's just scoop that feature out and subtract it, and then we'll do a comparison. Okay, so let's hover over that feature. We can get the correct angular deviation. That looks about right. We want to remove the trimming. We'll have a surface extension, keep mesh visible. That all looks good. Let's see what we get. Okay, so the fit is tolerance is 0.1, so we could probably reduce that a bit to get a tighter fit. So let's try 0.02. Let's try that. Okay, that looks a bit better. You can see we've got a better fit over that region. Let's hide the mesh. Bring back the part. And we can scoop that region out. So we'll use the cut bodies. This time we'll keep the back side and say, okay, just delete that and perhaps add a little blend in there as well. Okay. Right. Like I said, there are features at the bottom. I'm just not going to bother doing those for now. We've reasonably quickly used a variety of tools to create a prismatic part with a few freeform surfaces included. So let me show you the comparison. Let me bring back my mesh. So on the reverse tab, we've got the compare cloud mesh. So this is a specific compare command, which is to compare meshes or point clouds to solids or surfaces. So it's a dedicated command rather than using the compare in the analysis module, because that would be comparing solid bodies to solid bodies or solid bodies to sheet bodies, for example. So the difference is this is comparing to mesh and point clouds. So if we select that, first of all, we have to select the point cloud or mesh. Next, we select the body to compare. That's my solid I've just created. Then we have a third step, and it's not relevant in this example, so I'm just going to skip it by doing a right click. And here we've got our comparison. Okay, so I'll turn on the smooth color bar. It looks nice. Yeah, so we can see we can turn off or on any of these colors and just have a smaller range if that's what you want. You can change each of these values. It's fully editable, and we can also come in and hit a little trick here, okay, is to change to the intersection point, because otherwise, if you hover over, the whole thing goes blue and you can't see where you're selecting your points. So let me turn, let's keep multi-select off. So let's come in here and say we wanted to find out the deviation here is probably quite high, probably the highest region on the model. And we can come in and get the exact information of the deviation by coming in. If I turn multi-select on, I can pull out a few regions in one go. And when I confirm by right-clicking, you can see we get all of that feedback information. So you can verify if your model is within tolerance or not. So you've got to remember that the mesh is just a guide, and we did some alignments to straight up and down and flat surfaces to make sure we had a sensible and square part that we were making. Okay, so that is the end of my first demo. I think we're doing okay for time. So I'm going to go back to the PowerPoint. And hopefully you're all still with me. The next one is looking at a more free-form part. So the first one was mostly prismatic, and this time we're going to be looking at an imported point cloud. So that's what this orange blob is here. Because it's an imported point set, there's no surface normal information, so you can't see really what the part is going to look like. So we're going to convert the point cloud to a mesh and make a high quality mesh by doing some smoothing and refinements. And then I'm going to do a few different things because I want to just take the top skin and create a surface and create some nice features out of these holes and slots. So I'll do some mesh editing. Okay. So we've got two dedicated commands currently, which are adapting the mesh to features. And then I'm going to create a patch surface. So the method for doing this is to create a grid on your mesh, and we've got an automatic tool for doing this. We can project that grid onto our mesh, and then we can create our surface, our patch surface from that. At the moment, the mesh cleanup will fix loads of problems in the mesh. So if you do a mesh smoothing or a project elements, it can cause some corrupt triangles. So in the next version, we're going to build the, when I say next version, I mean the next software update as well. We're going to include the mesh cleanup. So the mesh fixing of, say, intersecting triangles and overlocking, just problem areas in the mesh. We're going to try and build that into the command, so you shouldn't have to do it. But it's really useful to know about anyway, just to verify that mesh. But at the moment, it's a manual step, so you'll see me doing it in Designer. All right, so without further ado, we're going back to Designer. I'm going to open a new model, and it's going to be my point cloud. So it was a TXT file that I imported. into, and then I've just saved it as a VDF. All right, and the reason I did that was basically just so we had a good alignment to start with, and so I could create some slots to keep the demo a bit shorter, because we've already seen the alignment now. So here's my point cloud. It's just an orange blob, so you can't really see what's going on. So I've got empty layer, which is active, and I'm going to use my, let's have a look at the one-click mesh, actually. So before I use the cloud to mesh, so if you have a look at the one-click mesh, you can see that we've got all those options in. So we've got the option to filter points. Obviously, you've got the mesh management. You can't not do that. You can choose to fill gaps or not. You can choose to turn on or off the refining and the smoothing and set the colors. So it's really just an accumulation of some other commands in Designer. That is the purpose of the one-click mesh. I'm going to use the method that I prefer because I like to have control. So I'm going to use the cloud to mesh, and again, I'll just use the default options, apart from I've got that cloud reorganization on. And here's the feedback. I've got 200,000 triangles. All right, you can see, hopefully you can see, we've got some holes in there. So rather than to fix them manually, I'm going to have a look at my dialog, and you can see we've got an option there, which is close holes. If I select that option, I've got my automatic preview on. So as soon as I select a different option, you can see the calculation is happening. All right, so we've fixed them holes. I'm happy with that. We've chosen to keep the original point cloud. All right, I'm just going to hide it, otherwise you can't see anything else. Now I'm just going to do a refinement step. Just keep the default. Sorry, I didn't select my mesh. Right, so we've refined our mesh ever so slightly, and we'll just do a bit of a smoothing as well. Let's do maybe 3. Oh, not 63. We'll do 3 smoothing passes. I think just by having a play around, you'll get the idea of how many to try out. It's just a bit of trial and error and getting to know the parameters. All right, so we've smoothed that out. And if we have a look at this mesh that we've created, it looks like a really nice high quality mesh that we've just created pretty quickly. You can see that we've got some noise here that's turned into a separate region of mesh. So if we just hide that guy, get rid of those, that's garbage. But looking from the bottom, you can see obviously it's a 3D part, and we've picked up some of these edges all around the part. And I really am only interested in the very top skin of the part in order to create surfaces. So what I'm going to do is split the top face off. And in order to do that, we have a dedicated command that lives on the solid tab currently. I think we're going to put it on reverse tab as well, called split mesh faces. So we can select that. I'm going to use my angular deviation and hover over my part to get the feedback. I'm going to increase this value until we've got what I think looks like everything. That'll do on that top face. And select it, and it's going to separate that top face into just that, a selectable face, rather than it just being a blob of triangles. So you can see that we've got the outline created of that face. That's just a bit of feedback. So also you can see I'm probably going to have a couple of holes in here that will need fixing. So I'll apply that. At the moment, it's still just one mesh, okay? It's got a face separated out. How easy it is for you to see that. So we've got separate faces. But now it means I can use the remove face command, so just a generic CAD command to, let's extract that top face from the main body. Okay. So now we've got that. You can see we've got that top face I just created, and that's the original. Not interested in the original, so I'm just going to get rid of it. Oops, I just did the wrong one. Let's undo that. I deleted the wrong one. Let's delete the right. Right, so we could see that we were going to have some holes in here. That's a good opportunity for me to show you the fill gaps command. Okay, so we've got this fill gaps. It's a new mesh hole filling command. We can select that, select the mesh that we want to fill. It's going to highlight all of the holes for us in a nice dark blue color so we can see what we're doing. I'm going to choose to select. In fact, let's turn multi-select on because I'm going to select these guys, select this guy down here, and select these. So I've got no holes. And we'll do a nice filling operation. Okay, when they've gone green, that means they've been filled. So we can right click and accept that. So next I want to use my adapt to circle command underneath fill gaps in order to get some perfect circles in this region here. All right, so I'm just going to say force radius, make that active. Reconstruction distance, I'm setting that to 3. And then I will select my mesh. And again, it identifies the boundaries for us and we can select it. So if we have a look at our dialog, you can see that it's got 6.5. So we can say maybe that does want to be 6.5. Zoom out. So it's just going to recreate that hole for us, but it's not going to be the perfect radius. All right, and that is blending perfectly into our mesh. So I'm going to do the same operation on my second hole. See, it picks out all the boundaries, select my hole. It's going to find the radius for me. It's got it set to 3.7. Let's just say it should be 3.7 exactly. And then it's going to rate that for us properly, and it's modifying our mesh. Okay, perfect. What I've got on another layer, something I prepared earlier, okay, you can see them now because they're selected, are some slot geometry. So you could have created this maybe by probing or by measurement. Because what I've got really is quite an untidy, jagged mesh edge. So I want to tidy that up first before I create a surface. So if I say adapt to element, I can select my mesh. I'm going to change my reconstruction distance to 3. Just something I found that works. Windows select those guys. And you can see that we've got nice slots perfectly created in our mesh, which is nice. Great stuff. We'll hide the wireframe now. Okay, because we extracted this top layer out, we've got a bit of a jagged edge going on. So I'm going to run another smoothing pass. Let's just do 3 again. And it's this smooth borders really that I'm interested in to give us a nice smooth edge that's not jagged. All right, so that looks pretty good. I'll leave it as that for now. And at the moment, it's that smooth edges that could possibly introduce some corrupt triangles at the edges. So I'm just going to run the mesh cleanup operation with a tolerance of 0.1 and select my mesh. You can see that it's identified some problems and fixed them for us. That's great. So we didn't have to do anything that difficult. So now I'm going to use the grid on mesh function to create that patchwork. I can select the mesh. So it's not a manual process, this. It's worth viewing from the top to see what that patch is going to look like. And make any changes. I'll just probably keep it the default as 10 by 10. You can edit the sections if you want as well and do it a bit more manually. I'm just going to use the defaults. And then the next step is to project these elements. And we have to use the Z direction. Selected all the wrong stuff. Let's do that again. Let's select my wireframe in the top one, and I need to choose to imprint. All right. And my destination is this mesh. And we'll let that calculate. It does take a couple of seconds to do it. That's why I made sure I got all my settings correct to start with. So you want to make sure you're imprinting and not using the normal to entity, but doing the Z direction. When this is done, I'm going to have a nice patchwork quilt imprinted into that mesh like so. So now I'm going to run my mesh to surface command. So it's the same command that I've used before to extract the 3D surfaces on my previous model. I'm going to choose to have, not to remove the trimming, I want to unite my surfaces to make a single surface. Surface extension needs to be 0. My tolerance can maybe be 0.3. And I get rid of the mesh. So oops. Let's select my patchwork mesh and create this freeform surface. If we look down at the bottom left corner, we're getting feedback on what the system's doing. How many surfaces it's managed to create on how many meshes. So if you've got corrupt mesh geometry, it's going to struggle to create a nice patch surface on top. So that's why it's good to fix any problems. Okay. Yeah, so we've united into one surface, 604 patches. So one of those is the mesh, and this is the surface model. And maybe you want to validate this to make sure it's an okay surface. So validation can tell you it's okay. And I can run a compare. I'll probably need to turn on my mesh, select that. Then I need to select my what to see surface. There we go. And then I need to skip this step. So this step is if you have a, let's say a huge solid model and you've only got the scan of a small region of it, you just pick the region that you want to compare. So you're not comparing the entire body, which you're not interested in. And then we get the results like so. Yeah, so we could come in here and then obviously pull out some key points. So if I just turn my multi-select on, we can say we'll have a label there and there, here. Let's go in this region here, in this red patch. Okay, and we can just get the analysis of how good that surface is. Okay. That is my second demo. I have included in the dataset, I know you haven't got it yet, but I will be providing it with this presentation and with the recording, So using the same method, the grid on mesh, okay, it doesn't have to be the only way you create that patch surface. So here's a different example that I've done. I'm not going to do the live demo now. But using this bike seat mesh example, you can extract the edges using extract edges. I've put the commands here that you could use. You do an offset. You have to project on work plane, so you get a 2D curve. Then you do an offset inwards or outwards. And then all I've done here is draw some lines using the line command, projected that into my mesh and created my surface. And then I've even given it a thicken operation. And then you could go ahead, scale it, 3D print it, do whatever you want with that model. So the grid on mesh is one approach, but you can create those patches any way you want for your freeform surfaces. It all depends on the model that you're working on, the topology of it. So just to summarize, I've done 2 demos. I've tried to cover as many of the reverse functions as possible. Hopefully you were able to absorb it all. You can watch it back if necessary. So we've got the prismatic, where we started with the point cloud acquisition, doing the scanning and the probing. Point cloud editing, doing some alignments and merging and filtering to create a lightweight data set. Then we created an alignment for the CAD, so we could do some nice reverse surfaces. We extracted planar and cylindrical surfaces from our mesh model, and we created some relatively simple freeform surfaces. Did a bit of direct modeling with our Booleans and a couple of blends. Did a comparison analysis. Then we had a look at some more freeform geometry, where I, rather than scanning directly in, I used a point cloud that was imported. And then I did some mesh modification by separating and splitting the mesh faces and tidying up the features by using the adapt to circle and adapt to elements commands. Then using the grid on mesh to project patchwork into the mesh and to create our final surface model. And we ended up with a comparison there. Okay, so I think we did quite well on time actually. And thanks very much for attending. Appreciate it very much. Happy Easter. Stay inside and stay safe. Thanks, guys.